Okay, so I'm basically putting a bunch of different videos together as a step-by-step thing because I know the majority of people don't want to watch individual stuff being assembled. Anyway, I'm in the middle of assembling the battery pack for the Aosenma G037. Okay, for those of you who need a refresher, this is the battery pack, the original factory battery pack that comes with it. Okay, unfortunately they don't make those anymore and they don't sell them anymore, and if they do, they're very expensive and they're hard to come by. Okay, I did find a website that had them and they wanted $149 a piece for them, which is ridiculous. Okay, anyway, so this is a finished unit assembled already, as you can see from the kit, and they're identical. Okay, so if you take the cover off the original and you place it next to each other, they're identical. Okay, as you can see here, trying to get a light going. Okay, they're identical. See that? Same size, same width. Oops. Same width, same plug configuration. Okay, this is the original purchased. Has a little LEDs in the back. This is a 3D printed version that I developed. This is a Zippy Comet 14.8 volt S4 at 2800 milliamps. Now I know that this is nowhere, it's not as close to 4700, which originally came with this one, but this is pretty much the size and voltage that will fit inside these factory cases or the replica of a factory case. Now, with that said, you can get a battery pack for a Phantom. I believe it's a Phantom 2 or a Phantom 3. If you want to go that route and rip it apart, take it out of the Phantom case and retransplant it in one of these, and you'd be good to go. Now, the only drawback on the Phantom batteries, they're what you would call smart batteries, which are connected to a board. It makes it pretty much impossible for you to use that battery pack in anything else but a Phantom, except for the actual physical battery. I did watch one guy tear one apart, and it was a bloomin' nightmare because of the way the wiring is and everything. It's very narrow and short wiring because it's going from the battery straight to the smart thing. So you're going to have to, if you're going to use one of those batteries, you're going to have to use either an extended cable, or you're going to have to solder a XT60 onto the leads. Okay, and that in itself is dangerous. I try not to solder these things if I can absolutely avoid it because of heat transference. All it takes is for the heat to travel down the wire, gets inside the battery, and you could cause an explosion. Don't want to do that. Okay, especially not this close to a battery while you're soldering. Alright, so the kit that you've seen in previous videos, which previous cuts of this video, show the individual pieces. Now, the individual pieces are basically designed to allow you to still customize the battery pack if you want. For example, these little locking ramps, they basically fit on these. They fit on the top right here. You epoxy them on like that. These line up with the same locking mechanism as these do. Okay, so if you don't want to have to take this, take it off your factory battery every time and then plug it in like this. Okay, if you don't want to do that, these will take the place of this. Okay, so you just have to solder those in place of the original faceplate. Okay, and it works. Okay, So this way, if you have a multiple of these, you can just slam them in there and you're ready to go. You don't need this. Okay, that's just a matter of taste, however you want to do it. Either way, it'll work. Okay, so in this case, I'm not going to be using these. These spacers, there's two types of spacers that come with them. Okay, there's the little ones. These are the 1/4 inch, and then there's a 1/2 inch, which is double the size. Okay, it depends on how you do your battery layout. In this case, what I've done is, if you look in here, I've placed one there and one here. Let's see if I can get this in there. See the little spacers? Now these spacers will hold the power panel, okay, in place, so when you push in the battery pack, this won't be pushed in and break. Okay, so this basically will line up as you look at it like this. So in other words, it will slide in. Now, I've done one little difference here. I've actually made an extension cable, and I'll show you why. Okay, so you would basically pull this through like this. That slides into place right here. I'm gonna have to wedge that in there. There we go. So basically, as you can see here, this sits in place like this. Okay. Now this is only, okay, and you would epoxy that in there. So now your wiring mechanism and your plugs are in position. Okay. Now, since this battery is so small, what I've done is so I don't have to solder. Now, the other option you have is you can actually solder a female XT60 on the back of here, which is this one. So you have like an L. Okay, so basically it would be like this. Okay, so if you're looking at it from the front, the other piece would be in the back, facing the other way. Okay, like this. Okay, this way you just plug the battery directly into that plug on this side. Okay, so basically if you look at this, if this was the female, okay, that would be attached to where the wire goes, and then the battery would plug into this. Okay, those are your options. The only thing is because this is PLA plastic, which is a lightweight plastic, the heat of the soldering may melt the panel. Okay, so the other option is to carve out the holes, solder these together, and then slide this whole piece in and epoxy around it. That's another way of doing it. Okay, it all depends on what you want to do. Me, in this case, I decided just to make an extension cable that runs the entire length. This is still drying, it's still epoxy. Runs the entire length of the case. So basically it sits in there like this. See that? Okay, because there's enough room with this battery. Then this battery slides in like this. Oops, other way. It goes this way. Okay, so it's sliding this way. Slides in like this. The battery is then placed in like this. Oops. And this wire comes all the way back this way, and this comes around this way. Okay, so and it plugs in. So that will give me the connection that I need to make it work. Okay, now I have a 1/2 inch of space between the inner wall and the outer wall of this battery. Okay, that all depends on how tight you're going to squeeze that. Now, if you could find a 3,000 milliamp battery, or if you're going to use a phantom battery, you're not going to have that kind of plate. So you're going to want to solder the female connector directly to the male connector on the back. So then, or otherwise, solder the cable from the battery directly to the connector. That's another option. Okay. There's, like I said, there's different ways you can do this and make it work. Either way, it does work. I did test it with this one. Unfortunately, I didn't have a 14 volt battery. I only had a 11 volt battery of this size. Okay, but it did work, and the Aosenma did fly with an 11 volt battery. Okay, so it will fly with an 11, but it's designed to fly with a 14 volt battery. So anyway, so then once this is all assembled and glued, okay, then this piece is then epoxied together. This is going to basically be a disposable battery pack. Okay, once everything's connected and inserted and sealed, it will be glued shut. So this will be completely glued. So it will be a non-removable battery. It's basically a disposable. For me, it's okay because I own the 3D program, so I can print out as many of these as I need and manufacture as many batteries as I want. If you're interested, like I said, I am selling these probably for about 25 bucks for all the tools you need. Okay, the battery case and the boards and all the little accessories. Okay, and I'll even throw in the X connectors. So but I was going to throw in some wires, but then again, everybody who's going to basically be working on this will have to use their own wiring. There will be a short wires with it, probably about 3 inches, or about 3 inches, about this long, for those who just want to solder it directly to the plugs. If you want to do custom, you're probably going to have to cut your own wires. But the most important part of this kit is the box. Like I said, not really sure yet. 25 bucks seems to be a fair price. Don't know yet. I may have different levels. One would be the battery compartment with all the accessories for the battery minus the connectors and the wiring. Okay, because most people in this line of hobby usually have spare parts. Okay, and then if you want part 2, then there could be second part would be the case with all the electrical, and maybe if I really want to have pre-made ones that are already made, they'll basically be a battery pack fully wired with an actual battery inside. Okay. Then again, just so you know, they won't be 4,000 milliamp batteries like the OEMs, because we're looking at the only place you can get those is if you scavenge them out of a Phantom battery. Okay, they'll probably be these 28 milliamp batteries. Now, I will take this out and see how long the drone will fly on 28 milliamps. It is a toy, so it's basically a decent toy drone. Even though this is nice to have, but if you can't get it and it's not worth, buying a Phantom battery and butchering it, because even Phantom batteries are expensive, they're 100 bucks. Then this one here was 35 bucks on eBay, shipped in 2 days. At 200 milliamp, that drone will at least get 20 minutes, if not more. I know this one pulls close to 30 minutes, depending on how you fly. So I mean, it gives you the option and it gets the bird in the air. That's all that counts. So, alright, well, I'm going to end this track. So hopefully I'll be able to splice all these individual videos together and go from there. So please don't judge me on my video splicing, because that's just not my forte. But I'll give it a shot. Alright guys, take care.